A linked list is a data structure consisting of a group of nodes which together represents a sequence. Under the simplest form, each node is composed of a data and a reference. In other words, a link to the next node in the sequence.
I'm Daniel Japmuta. I will discuss linked list basics. Linked lists and arrays are similar since they both store collections of data. The arrays feature all follow from its strategy of allocating the memory for all its elements in one block of memory. Linked lists use an entirely different strategy. Linked lists allocate memory for each element separately and only when necessary.
I'm Michael Custodio, and I will discuss the introduction of linked lists.
The list and arrays. This is the examples of list and arrays. This is the list. This is the arrays, the nodes and pointers. This is the examples of nodes and pointers. The single linked list. This is the examples of single linked list. The double linked list. This is the examples of double linked list. The circular list. This is the examples of circular list.
Good day. I'm Cedric Rosado. I will discuss the advantage and disadvantages of arrays. Advantage. The linked list advantage are collected because of the array disadvantages. Array disadvantages are: the first one is array size, and the second is memory allocation, and the last are insertion and deletion. Disadvantages of arrays. The first is array size. In case of dynamically resizing the array from S to 2S, we need 3S units of available memory. The second is memory allocation. Programmers allocate arrays which seem large enough. This strategy has two disadvantages. A. Most of the time, there are just 20% or 30% elements in the array, and 70% of the space in the array really is wasted. B. If the program ever needs to process more than the declared size, the code breaks. And the last are insertion and deletion. Elements into the middle of the array is potentially expensive because existing elements need to be shifted over to make room.
I'm Kenneth Ancheta. I will discuss the insertion of the node. Insertion at the top of the list. Steps are: create a node, set the node data values, and connect the pointers. This is the example. The next one is insertion at the end of the list. The steps are: create a node, set the node data values, and connect the pointers. Another example. Insertion in the middle of the list. The steps are: create a node, set the node data values, break the pointer connection, and reconnect the pointers. Last example.
I'm Aldrian Figuracion, and I will discuss how to delete a node. Deleting from the top of the list, and the steps are: break the pointer connection, reconnect the nodes, delete the node. And this is how it works. Deleting from the end of the list, and the steps are: break the pointer connection, set previous node pointer to null, delete the node. And this is the procedure. Deleting from the middle of the list, and the steps are: set previous node pointer to the next node, break node pointer connection, delete the node. And this is how it works.